Good morning.
Good morning.
How are you doing?
We are doing fine.
Fine.
Okay, I hope everybody would hear me.
Yes.
That's good. I hope your holiday is going on well.
Yes.
It is.
Yes.
It is. Okay. I'd like to to this session. Could somebody please tell me what your expectations are for the session? Hello. Nick, are you saying something?
Yes. Some of my expectations for the session was that we could do a brief recap on where we left at the topics you had covered when you were at school, in form of revision as questions.
Is there any that is? Yeah. Is there any particular one you feel is a really challenge?
There is none in particular. Just to refresh.
Okay, hear you. Anybody else? Benja? Benja, you didn't hear what he said?
Yeah.
Speak a little bit louder.
Yeah. I'm just expecting that we're going to do some revision.
Yeah. Seems you have a problem with your network, Benja. Is Umuro online? Yatani? Brian, one's here?
My expectations are go through some topics, especially on density and pressure.
Especially?
Especially on density and pressure.
Pressure and, okay.
Yes.
Okay, one thing, we may not be able to cover everything if there is a limited time, but we'll try to do as much as possible. Okay?
Yes.
Nick?
Yes.
Benja?
Yes, sir.
And let's hear the rest, please. Don't just remain quiet. Let's hear others speak.
Yes. Yes, sir.
Yes.
Yes, sir.
Yes, sir. Yes.
Okay.
Yes, sir.
Yes.
Yes, sir.
So maybe to start with, physics starts with introduction to physics. That's where we began the very first session, isn't it?
Yes.
Somebody remind us, what is physics?
It is the study of matter with its relation to energy.
Yeah, good, good. It's the study of matter and its relation to energy. Benja was saying something.
I was saying, I was answering the question that.
Okay, okay. Nyonji. Nyonji, I saw your hand raised. Okay. What are the branches of physics?
Mechanics.
Mechanics is one. What does mechanics deal with?
Mechanics deals with how objects behave under the influence of force.
Yeah, good. Lekishon, I can see your hand up. Lekishon? Lekishon, we're waiting for you to say something. Okay, somebody, another branch? Branches of physics, please.
Thermodynamics.
Thermodynamics, Brian, good. Which
Deals
deals
with
with?
the study of transformation of heat to and from other sources.
Study of transmission of heat and its transformation to other forms of energy, good.
Forms of energy.
Yeah, good. Next.
Geometrical optics.
Geometrical optics, which deals with?
This deals with the behavior of light as it passes through very.
Malcolm.
Waves.
Waves. Nick is saying something?
Yeah, I was on geometrical optics.
Yeah.
And this deals with the behavior of light as it travels through various media.
Yes, that's right. Jakai, you said waves?
Yes, waves.
Yes.
Deals with the propagation of energy through space.
Through media, not just space.
Yes.
Okay, next.
Electricity and magnetism.
Electricity and magnetism.
Deals
yes,
with
yes.
Deals with the relationship between electric currents and magnetic fields.
Yeah, that's right. The other branch? Okay, what did you say?
Nuclear physics.
Nuclear physics, which deals with what? What does it deal with?
Behavior of particles that constitute the nucleus.
The behavior and properties of particles that constitute the nucleus, that's right. Is there any other branch? Caesar?
There is no more, sir.
So basically, those are the broad branches of physics. So what are some of the advantages of studying physics?
Zacharias.
It is a career subject. Yes. Anything else apart from being a career subject? Any other benefit of studying physics apart from it being a career subject? Aaron?
One can know the reason as to why phenomena such as why a liquid goes up a straw happens.
So we're able to
Yes.
Lection?
Yes.
Yeah, you saying something?
It helps in skills on technologies.
Yeah, it's really a big tool in technology because it is physics that really informs technology. It's applications of physics that are applied in technology, and there's so many other fields, yeah?
Yes.
Any other? Nyaku? Buyaku?
It imparts scientific skills such as analyzing and evaluating data.
Yeah. It would help in impacting skills, observation, analyzing, evaluating, and making conclusions. Okay?
Yes.
Aaron?
One is able to carry out daily tasks such as changing a tire through application of knowledge in physics.
Yeah, there's some things and know which way and what amount of force to apply without breaking the nuts, yeah?
Yes.
Mm-hmm.
Yes.
Nick?
No, mine was answered.
It was answered.
Yes.
Okay. All right, what is the relationship between physics and religion? Yes, please.
Physics and religion,
Yeah.
they are related in the sense that both of them portray a sense of orderliness.
Orderliness in the universe.
Yes.
But again, we need to look at it from the context of what religion teaches, which is correct. It's what you're saying is correct. But what you say is that religion teaches that God created the universe, isn't it?
Yes.
Then physics says there is orderliness in the universe, therefore it is in agreement.
Yes.
What is the relationship between physics and technology? The relationship between physics and technology?
The
Physics
relationship
comes up.
between
The relationship between physics and technology is that physics comes up with gadgets that are used in technology.
Is it physics coming up with gadgets or coming with principles? Which is which? Because the gadgets are coming out of technology, yeah? But these are applications of principles in physics, right?
Yeah.
So a technology actually borrows a lot of principles from physics. What's the relationship between physics and history?
The relationship between physics and history, we can see that physics has contributed to the development of machines that are used in dating the historical maybe objects.
Some technology, some aspects like carbon dating.
Yes.
To determine the age of fossils.
Yes.
And of course, with equipment for navigation, yeah?
Yeah.
What is the relationship between physics and biology?
The knowledge of lenses in physics has made us in the microscopes which are used in biology to study the cell, the basic unit of life.
Brian?
I wanted to say the same thing.
Brian, your audio seems to have a problem. Sorry, it seems like my connection is getting lost. Okay, we agree that physics plays a very important role in life. A very important role in life because it is one subject that has very, very many applications. Sometimes right from Nick.
Yes.
Oh, I thought you're speaking, but we're saying that physics contributes so much in so much. And some of you there, maybe you need to check your audio. It's coming out like there's some sound effects that are coming out like somebody's playing a guitar or a keyboard, especially for Brian, yeah? So physics, we agree, is an important and plays a very important role in all aspects of life, right from electricity, electronic devices, in medicine, all aspects of life have applications to do with physics. Even the very motion, construction, and all this involve physics. And we all agree that it is important to study physics. Mwanzia?
Yes.
I thought you're saying something. So with the next topic, we talk of measurements. Measurements may not be so much oral, but we can define a few terms that we use in measurements. You remember the International Conference on Units?
Yes.
Remember that?
Yes.
And came up with how many basic fundamental quantities?
7.
How many what are fundamental quantities? How many are they?
7.
3.
7. Good. And which are the 7?
We have length, which is the
Length.
distance from one point to another. It's SI
Lesser unit.
Meters.
And when we talk
And
of
its
unit,
symbol
please,
is
we talk of meter, not meters, yeah? Because it's
okay.
unit, it's singular. So, when you're talking of SI unit, we
Yes.
talk of it in singular. That's length. Malcolm.
Mass.
Mass. What is mass?
Mass.
Yes, what is mass?
The
What's the
quantity of
definition of
matter in
mass?
an object. The
quantity of matter in a
in an
substance.
object.
That's right. What is SI unit?
SI unit. Kilogram.
Kilogram. Charles, bro.
Time.
Time.
Yes.
What's the definition of time?
Time is the time is a measurement of a duration of an event.
Time is a measurement of the duration of an event. Good. What is the SI unit of time?
A second.
Second. Good. The next unit is the next unit. We have 3 so far. Aaron. Aaron. Aaron, I think you're not audible. Matilu.
Luminous intensity.
Luminous intensity. And it's a measure of what? What is luminous?
Is the measure of the amount of light that something produces.
Okay, it's easy to do about light, yes. And the SI unit?
Is candela.
Candela, good. The other one? So far, how many do we have? 5? Alvin? Alvin, check your audio. Audio is not coming out very well.
I wasn't speaking yet.
Okay. Yeah. Which is the unit? Which is the
thermodynamic temperature.
Thermodynamic temperature. And what is
the measure
thermodynamic
of the
temperature?
Measure of absolute temperature.
Yeah. What is SI unit?
Kelvin.
It's a Kelvin. Good. The other one, unit, which is the other basic, the other fundamental quantity?
Electric current.
Electric current. Caesar, that's good. What is electric current?
It's a stream of charged particles moving through an electrical conductor or space.
Okay, but really the definition is rate of flow of charges, yeah?
Yes.
The correct definition of electric current is rate of flow. We come across that as we study current electricity. Don't worry. What is the SI unit of electric current?
Ampere.
It's the ampere. And please don't make the mistake of writing ampere with H because students make that mistake. Ampere is A-M-P-E-R-E. Yes, the students make a mistake of writing A-M-P-H. Doesn't have an H, please. Okay?
Yes.
What is area?
Area is a measure of extent of a surface, usually expressed in SI in square units.
A measure of the extent of a surface, good, usually expressed in square units. What is the SI unit of area?
Meter squared.
Square meter or meter squared. It's good. What is volume?
Volume is the space occupied by a substance.
The space occupied by a substance. SI unit?
Cubic meter.
Cubic meter.
The cubic meter. Cubic meter.
Yes.
Now, there's something related to volume called capacity. Ever heard of capacity? Capacity is related to volume. So what is capacity?
Amount of liquid or gas that a container can hold.
Liquid or gas? You know, if gas can be a little bit tricky.
Liquid.
Brian?
the amount of matter that can fill up a substance.
Brian, the sound seems not be coming out.
I said that it is for the amount of liquid that can fill a substance.
Okay, yes, it is the amount of liquid or grain, not gas, yeah? The amount of liquid or grain that a container can hold. The amount of liquid or grain that a container can hold.
Yes.
That is capacity. We notice that capacity, actually the SI unit of capacity is not the cubic meter.
Meters.
It is not cubic meter, though it's related to volume and can be expressed in that. The SI unit of capacity is the liter. We talk of liters, yeah? The liter is the SI unit of
Capacity.
capacity. Though we can still express it in cubic meters, you can express it in cubic centimeters. Really, that's why I said capacity and volume are closely related. Okay.
Yes.
What is density?
The mass of a material unit of volume.
The mass of material
Per unit volume.
Per unit, the mass per unit volume of a substance, yeah? The mass per unit volume of
a substance.
What is the SI unit of density?
Gram per cubic centimeter.
The SI unit?
Grams per cubic centimeters.
Gram per cubic centimeter is not correct. That's not the SI unit. Yes, you can express density in grams per cubic centimeter, but it's not the SI unit. Remember, it's talking of mass per unit. Yes, kilogram per cubic meter. Remember, density is a derived quantity, isn't it?
Yes.
Yes.
It is a derived quantity. What is it derived from?
Mass.
Mass and
volume.
And volume, isn't it?
Yes.
So to get the SI unit of a derived quantity, we look at the quantities from which they're derived.
Yes.
So the SI unit of mass is
kilogram.
The kilogram, isn't it?
Yes.
And the SI unit of volume is
cubic meter.
Cubic meter. So because we are dividing mass by volume, now it will be kilogram per cubic
meter.
Okay?
Yes.
Yes.
Of course, you can determine density by various methods. This one we may not go through them orally, yeah? Because you have the method, we just measure the mass and the volume, determine the volume and all that. Okay?
Yes.
Is there anything else we need to look at in terms of measurements?
Accuracy and sensitivity.
Yes, accuracy and sensitivity. Now, think of something like measurement of length using a meter rule. That is what we'd use in the laboratory, isn't it?
Yes.
Yes.
Or a ruler. A meter rule will be 1 meter long from end to end. That's why it's called a rule, yeah?
Yes.
Yes.
And it is divided into centimeters.
Yes.
The division is called calibration, isn't it?
Yes.
Yes.
So it is calibrated in centimeters, then the centimeter is divided into millimeters. Okay?
Yes.
So what is the smallest calibration on it? It is 1 millimeter, isn't it?
Yes.
Yes.
That smallest calibration is what is called the sensitivity. of an instrument.
I
The
beg your pardon,
smallest,
sir.
you're saying the smallest calibration on an instrument. I think there's something about, I don't know why you have an echo, yeah? The smallest calibration, the smallest division on an instrument is known as its sensitivity. Okay?
Yes.
Did you get that?
Yes.
The smallest calibration, that is sensitivity. Okay? When you look at your ruler or your meter rule, you can estimate about half of a millimeter. You can estimate about half of a millimeter. Of course, you cannot estimate a quarter. We cannot estimate 3/4 or a sixth, but half is possible, isn't it?
Yes.
So that sensitivity, if you divide by 2, gives us the accuracy. You get that?
Yes.
Accuracy is the sensitivity divided by 2. So the accuracy will be, yes?
Oh, continue.
We're saying when you take the smallest, what the half that you can estimate is, that is the half of the sensitivity is known as accuracy. Okay?
Yes.
But sensitivity, we have to be careful with it. We have to be careful with the term sensitivity, because it can mean something else. Take, for example, a thermometer, yeah?
Yes.
Now, we say we need to improve the sensitivity of the thermometer. The sensitivity can also mean how quickly an instrument responds. You see, like a thermometer, how quickly does it respond? Yeah, it can mean how quickly an instrument responds to, especially with things that require something to be sensed. You see, like a thermometer needs to sense the temperature so as to respond, yeah?
Yes.
So sensitivity can be a little bit tricky, so we must be careful with it. But when it's normally, in the normal use, sensitivity will be the smallest calibration, okay?
Yes.
And accuracy is half the sensitivity. So for a meter rule or a ruler, the accuracy is 1 millimeter. Okay?
Yes.
The sensitivity is 1 millimeter. The accuracy will be half a millimeter. That would mean we can measure using a ruler or a meter rule. We can measure a length of something like 10.15 centimeters. That would be 10 centimeters, 1.5 millimeters. Yeah? 10.15 millimeters. But we cannot measure 10.16 using a ruler. We cannot measure 10.14. It will either be 10.15 or 10.10 or 10.11. Okay?
Yes.
10.1, not 10.11, it will be either 10.10,
or
10.15, or 10.20.
Yes.
So, Sawa?
Yes.
Aaron, can see your hand up.
If you are asked how can the accuracy of an object be modified, what can you say?
No, that one will depend on what you're using. For example, when you're using a thermometer, we can increase the sensitivity of the thermometer by making the bulb thinner. You see, the bulb being thinner, it means that the heat will be transmitted quickly between the glass and the thermometric liquid, yeah?
Yes.
And we make the bore finer. We make the capillary bore narrower. If we make the capillary bore narrower, it means that the liquid will move a longer distance. And moving along a distance means you can calibrate it with smaller divisions. You can make smaller divisions on it. So both way it will increase the sensitivity, how quickly it responds to the temperature change, and also on the measurement. Okay?
Yes.
So that question will depend on what instrument we are asking. I can see some two hands up. I don't know who it is. Nick?
Yes. Before you move on, could you please the complete definition of sensitivity? You've said it's the smallest calibration.
I said the smallest calibration is the smallest calibration on an instrument. The smallest calibration is a division, yeah?
Yes, thank you.
The smallest calibration on an instrument. Then we said accuracy is half the sensitivity. Onil.
Yes.
You saying something?
No.
No, it's indicating that you're speaking. Okay.
Mwalimu.
So did we get that?
Yes.
Anybody with a question? Muyeku?
What about precision?
Precision and sensitivity will still be the same thing.
Oh, thank you, Mwalimu.
Yes. So we're done with the part of sensitivity, accuracy?
Yes.
Yes. Yes. Yes.
Okay. Now maybe anybody with a question on measurements? Once it's indicating that you're speaking.
No, I'm not speaking.
Okay. So can we move on? If there's no question on measurements, can we look at force?
Yes.
Force, yeah?
Yes.
So what is a force?
Yes.
What is a force?
A force is a push or pull.
Simply a push, a pull. A push or a pull on an object. Or you can just say it's a push or a pull.
Yes.
Now, when we're thinking of that, maybe before we go to the details of that, when you have quantities, physical quantities, Nick?
Yes, sure. Can you say that is a pull or lift acting on an object?
You see, if you're thinking of lifting,
yes,
to lift something, you either pull it upwards or push it upwards.
Oh, okay.
You see, if you are trying to lift something and you are on top, you'll be pulling it up, isn't it?
Yes.
If you're at the bottom, you'll be pushing it upwards.
Downwards.
So it's basically a push or a pull. That's a very simple definition of force. Okay.
And what about upthrust? Upthrust force and in relation to the definition of force.
You see, upthrust is the upward force that is acting on a body that is immersed in a fluid.
Yes.
Okay.
Yeah.
It's really an upward force. It's called upthrust because it's within a fluid. In some loose sects, it will be referred to as buoyancy in very loose terms. Yeah. Buoyancy.
Yes.
Okay.
Yeah. Thank you.
Excuse me.
So
Excuse me.
What I was saying, yes, sir. Yes.
When like upthrust, when you go too deep, where the liquid pressure is more than the atmospheric pressure, does
upthrust
Yes.
still work at that kind of depth?
Yes, upthrust will, as long as the object is immersed in the fluid to experience, because it is displacing the liquid. Okay.
Then why, yes, but then why is it not possible if, let's say,
Yeah.
for example, a submarine goes
Yes.
where to the extreme depth where the liquid temperature, no, the liquid pressure is more than the atmospheric pressure. At most of the circumstances, the submarine is
Yeah.
not able to go to submerge, and upthrust help in that.
Now, the thing is, when you think of something that is sinking,
Yes.
something that is sinking in, maybe for example, in water, upthrust would help in floating only if the body displaces a weight of fluid that is equal to the weight of the body. Okay, let's not worry so much about this. There's a topic on floating and sinking later in the course, yeah?
Yes.
But the fact that it's not floating doesn't mean there's no upthrust on it. When you have a body maybe falling through a fluid, for example, if it's falling, yeah? For example, when you drop a stone, there are three forces acting. There's the weight acting downwards, yeah?
Yes.
Then we have upthrust acting upwards, and we have, if it's moving, there's fluid friction, or what we refer to as viscosity. Okay?
Yes.
But what happens is there is an imbalance between the three forces. There is an imbalance, yeah? Such that now the weight of the body is greater than the upthrust and the fluid friction. That is why it falls downwards. It would float if there's a balance between the upward force and the downward force, okay?
Yes.
But the moment there's an imbalance of force, there will be motion in the direction where the force is greater. You know what I mean by imbalance, yeah? It means that
Yes.
force acting in one direction is greater than the force is acting in the other direction. Sasawa?
Yes.
I hope the question is answered.
Yes.
Okay. So saying we have physical quantities and they're categorized into two. We have vector quantities and we have scalar quantities. When you have physical quantities, you say they're categorized as either vector or scalar.
Scalar.
S-C-A-L-A-R. Scalar, yeah?
Yeah.
Yes.
Now, a vector quantity. Benja?
Yes, sir.
Ephraim? No, it's just indicating that you're speaking. Ephraim, your hand is up.
Vector quantity is a quantity that has magnitude and direction.
Good. A vector quantity is a quantity that has magnitude and direction. For example, if you told somebody just walk out and walk 300 meters or 200 meters, they can take 300 meters in any direction, they'll be following your instruction. Okay? Because you've not told them the direction in which to head. Or you can specifically tell them from this point, walk so many meters in a specified direction. Okay? So when you give the quantity and the direction, then we talk of a vector quantity. It tells you the size and the direction in which it's moving or acting. Are we together there?
Yes.
Yes.
The other one is a scalar quantity. What is a scalar quantity?
A scalar quantity is a quantity that.
Yeah, continue.
A scalar quantity is a quantity which has magnitude but has no direction.
A quantity that has only magnitude, good. So we have those two quantities, vector quantities, scalar quantities. So when you talk of force, force is a vector quantity. Yes, O'Neill? O'Neill?
Sorry, yes.
I can see your hand up.
No, I wanted to ask that question.
Yeah.
So I forgot
Okay.
to put it down.
Yeah, which question now? Pardon, O'Neill?
Yes.
What did you say?
The question that you had asked about scalar quantities, I wanted to answer. I had put my hands up, but I forgot to put it down.
Okay. So force is a vector quantity. Force is a vector quantity. And what is the SI unit of force?
Newtons.
The Newton.
Newton. Remember saying when we talk of SI unit, we give it in singular, not in plural, yeah?
Yes.
Yes.
Because you're talking of SI unit. You're talking of SI unit, not SI units, okay?
Yes.
So what are some of the effects of a force? What are some of the effects of a force?
Force can start motion.
Yes.
It
can start.
It can speed up motion.
Can stop motion. Yes.
It can change the direction.
It can change
Direction of a moving object.
the direction of motion of an object. Yes.
Force can distort.
Can change the shape.
Can change the shape of it. Yes.
Yes. Yes. Matilu. Ephraim.
It can slow or stop a moving object.
It can slow down. It can stop a moving object. Yes. Manzia.
Force can cause bending or breakage of an object.
It can bend or break an object. Yes. Any other? So what are some of the forces that we know? What are some of the forces? Some of the types of forces that you know. Ephraim?
Frictional force.
Frictional force. What is frictional force?
This is the force that resists motion.
It is the force that opposes relative motion between
two objects
that are in contact. Note, there has to be in contact, isn't it? Yeah, there's some 3 hands raised up. I don't know who they are.
Yes.
O'Neill? Which other force?
Upthrust force.
Upthrust. What is upthrust force?
It is the upward force acting on object immersed in liquids.
In liquids, in fluids, yeah? In a fluid.
Yes. Yes.
Okay. The other type, the other force?
Electrostatic force.
Electrostatic force. What are electrostatic forces?
They are forces that cause attraction or repulsion in charged objects.
In charged objects, good. Another one?
Gravitational
force. Yes, what is gravitational force?
Force that attracts.
Regishon and Nick, you're speaking at the same time.
If you can answer that one.
Regishon? Yes,
Force that
Nick.
towards the Earth center.
Regishon, what are you saying?
Gravitational force.
Gravitational force. Yes. What is it?
Force that attracts objects to the center of the Earth.
Is that really, yeah, okay, that's an aspect of gravity.
Gravity.
But gravitational force.
This is the force that is brought about by two bodies with given masses.
It's at the forces of attraction between two bodies of given masses. Of course, the force that we have attracting bodies towards the center of the Earth is the Earth's gravitational force. That's all. Another question?
Force. Magnetic force.
Magnetic force. What is magnetic force direction?
What's that? Attraction or repulsion?
The force
causes attraction.
That causes attraction or repulsion in magnets, yeah? Okay. Yes, another type of force?
Centripetal force.
Centripetal force. Good. What is centripetal force?
It is the force that keeps an object moving in a circular path.
It is the force that keeps an object moving along a circular path. Good. What other force? Aaron? Yes, another type of force?
Cohesive and forces.
Cohesive and adhesive forces. And what are these?
Cohesive force, this is the force of attraction between molecules or particles of the same kind, while adhesive forces, these are the forces of attraction between molecules or particles of different kind or of a different material object.
Okay, good. Any other? Any other? Okay, what is weight?
Weight is a measure of the gravitational pull on a body.
The weight is a measure of the Earth's gravitational pull on a body. Okay. And what is the relationship between mass and weight? The relationship between mass and weight? How are mass and weight related? Brian?
Mass and weight are related in the aspect that they both have magnitude.
They both have magnitude, yes, they are both physical quantities. But I'm asking that what we have a formula that relates mass and weight. What is it?
Excuse me, Chuck.
Yes.
Can you say that the formula that brings mass and weight together is weight is equals to mass times gravity?
Yeah, actually, that's the relationship I was asking. Good.
Yes, thank you.
Weight is given by
mass
multiplied by gravitational field intensity. Okay?
Yes.
Of course, what are the differences between mass and weight? One?
One of the differences between mass and weight is in their definition, which mass is the amount of matter in an object, and weight, weight is the measure or amount of gravity acting on an object.
Good. Another one?
Mass is constant while moving from place to place, while weight changes from place to place.
Good. Mass is constant everywhere. Weight varies from place to place. Okay?
Yes.
Yes, who has their hand up?
Mass
I see
is
some 4 hands up.
measured in kilograms.
Mass is measured in kilograms, which will return yes. Weight?
Weight is measured in newtons.
Good. Muyeku?
Mass is a scalar quantity while weight is a vector quantity.
Yes, good. Weight is a scalar quantity. No, weight is a vector quantity. Mass is a scalar quantity. Yes. Ephraim?
Mass is measured using a bin balance, while weight is measured using a spring balance.
Mass is measured using a beam balance. Weight is measured using a spring balance. Good. Okay?
Yes.
And of course, when you think of weight, where is weight greatest on the surface of the Earth? At which point? Along the equator or the poles?
The poles.
Ephraim? It is greatest as the poles, yeah? Because gravitational
Yes.
field intensity increases as you move from the equator towards the pole. And the reason is, what's the reason why gravitational field intensity increases? Is greatest at near the pole, at the pole. Why is it so?
The poles are closer to the equator, to the center than the equator.
Good. It's because of the proximity to the center of the Earth. The poles are closer to the center of the Earth than the equator. That's good. So, Sawa, anything we want to ask about force? Any question on the topic of force? Any question on the topic of force? Silence means there's no question, yeah?
Yes.
Yes.
What is surface tension? What is surface tension? Muyeku?
This is the force of attraction between molecules on the surface of a liquid, which make the surface to become like a thin stretched bag.
Thin stretched bag skin, or which is Muyeku?
It makes the surface to appear thin stretched, elastic.
A stretched elastic skin, not bag, yeah? Not bag, yeah?
Okay.
The force that causes the liquid surface to behave like a stretched elastic skin. Salim? Salim?
Yes, that's what I wanted to say.
Okay.
Yeah.
Okay. Now, there's something we need to look at surface tension. The liquid surface behaves like a stretched elastic skin. And we say that's a result of surface tension. But actually, if you read some books, will tell you that surface tension is the force per unit length of a liquid surface. The force per unit length of a liquid surface. They will tell you about coefficient of surface tension, but let's not go to the details of that. Let's just look at it in terms of this liquid surface behaving like a stretched elastic skin. Okay? And
Yes.
this is the reason why we'd have a razor blade. If you have a razor blade and we carefully place it on the liquid surface, what will happen? It will float. It will float, or a needle for that matter. But there's something you can do to make it sink. So what are the factors that affect surface tension? What factors affect surface tension?
One
Salim?
of them is
Purity of the liquid.
Purity of the liquid, yes.
Yes.
Nick was saying something.
yes. Another factor
Yes.
that affects surface tension is temperature.
That's the purity of substance. And so if you have some impurities, surface tension is reduced. If you increase the temperature, again, surface tension is reduced. If you increase temperature, surface tension is decreased, is or reduced. If you raise the temperature, and if you have impurities in that. Now, I'd like you to get something.
Me,
you
sir.
can, yes, please.
I have a question.
Yes, Caesar.
When in application of surface tension,
Yes.
can you say when people throw stones through the surface of the water, can that be an application of surface tension? When people throw stones and just see the stone floating through until a certain distance.
No, throwing a stone may really not be an application, and we don't talk of applications, we talk of effects, yeah?
Yes.
We talk of effects where we have insects walking,
Yeah.
mosquito larvae floating. You're talking of effects of surface tension, not really applications, yeah?
No problem. Okay, thank you.
Yes.
Mm.
Okay.
Yeah.
So I was saying that you can try something. You can make, you know how to make a paper boat, yeah?
Yes.
You can try this with water, I know that. Make a paper boat, then rub some soap on one end and place it on water and observe what happens.
Yes.
Or you can just take a matchstick. You see a matchstick? A matchstick, then one end of the matchstick, you rub soap and place it on water surface, maybe in a basin, and observe. You see what we say in the book, that the matchstick moves, yeah?
Yes.
Of course, it will move in a certain direction away from the end that has soap. That is expected. Sasawa?
Yes.
Is there anything you want to ask on force? Or we are good to go? I guess silence means we can move on, yeah? The next thing is pressure. Next thing is pressure.
Yes.
When you use the term pressure on a day-to-day life, it may mean a lot of things. You've heard of peer pressure, and many times you're told, oh, okay, don't fall prey to peer pressure. But peer pressure is not always negative. That's one thing we know. Sometimes they say that we are under so much pressure because we have so much work. We have so much to do, so there's a lot of pressure. But when we speak of pressure in the context of physics, we are looking at pressure as a physical quantity. You're looking at as a physical quantity, physical quantity that can be measured. A quantity that can be measured, a quantity that has units, and a quantity that has effects that can be felt or even observed. Okay? Somebody remind us, what is pressure?
Pressure refers to the perpendicular force acting on a surface. Maybe
Force?
I'm not sure.
You're not sure. The force acting per unit, perpendicular per unit. We talk of either perpendicular or normally.
Yes.
Yeah.
Yes.
When you talk of normal in our context, we mean perpendicular.
Yes.
So it's a force
Yes.
acting perpendicularly per unit,
Perpendicularly area.
per unit area.
Yes.
Okay, that is pressure. Of course, kuna mtu ana mtoto karibu. Okay, so we are saying that pressure is force per unit area. So when you want to look at the from definition, we are saying that pressure is equal to normal force divided by area. Sometimes they'll talk of thrust, force or thrust, okay? Just means the same thing. So what happens when you increase the area, keeping force constant? If you kept force constant and increase the area, what would happen to the pressure? Nick?
If the area is increased and the force is kept constant, this means that the pressure reduce.
Pressure would reduce. If we decrease the area, keeping force constant,
the pressure increases.
The pressure increases. Okay? So we notice that pressure and area, if we use mathematical terms, they are inversely proportional. Pressure is inversely proportional to area. This would mean that if, for example, we double the area, what would happen to the pressure? If we double the area, what would happen to the pressure?
Doubles.
Doubled. If we double the area,
it
what would happen
reduces
to the
to half
pressure?
of the pressure.
It
It will reduce by half, yeah?
Yes.
So the pressure would double
if the area was reduced to half.
If the area was reduced to half.
Yes.
So if we double the pressure, if we double the area,
the
pressure
will
is
reduce
reduced in the same ratio.
Yes.
Okay?
Yes.
Yes.
So pressure, we say pressure and area are inversely proportional. But when you look at pressure and force, they are directly
proportional.
They're directly proportional. Of course, when you think of pressure, virtually even liquids exert pressure.
Yes.
But in liquids, the pressure exerted does not depend on area. Does not depend on area. The pressure exerted in liquids does not depend on area.
Yes.
But depends on what does it depend on? Pressure in liquids?
Depth.
Depth. One, depth, yes.
And density.
What else?
Density.
Density. Density of the fluid, yeah?
Yes.
And of course, if we are thinking of moving from place to place, it will be affected by the gravitational field intensity. So.
Yes.
So what is SI unit of pressure? SI unit of pressure?
Newtons meter squared or Pascal unit.
Newton per square meter, but it sometimes also referred to as the Pascal
unit.
Pascal, not just Pascal unit, it's just called the Pascal. Eh?
Okay.
So 1 Pascal is an equivalent of 1 Newton per square meter. Okay.
Yes.
Yes, Nick.
I didn't have any question. I was just agreeing with your statement.
Okay. So what else we want to know? Is Pascal's principle, we know it? Pascal's principle, or the principle of transmission of pressure this is in liquids, not fluids, yeah? In liquids. What does it state? What does Pascal's principle state?
Pascal's principle states that force exerted in a enclosed liquid is equal throughout all points of the liquid.
Is it force or pressure, Nick?
Pressure.
It's pressure. Yeah, Aaron, can see your hand
Yes.
up? Yes. Aaron?
I just wanted to see that Pascal's principle states that pressure applied at one point of an enclosed liquid is transmitted throughout equally.
Is transmitted equally throughout the liquid. It's an enclosed liquid, okay?
Yes.
Of course, this is what is used in hydraulic machines, yeah? Is the principle that is used in hydraulic machines. So what are the qualities of the liquid to be used in a hydraulic machine? What are the properties that
It will be incompressible.
It should have a high boiling point and a low melting.
Low freezing point.
Low freezing point. And high boiling point.
Boiling point. Yes. Brian, that's what?
It should not corrode the parts.
It should not corrode the parts. Aaron?
It should
The
be
liquid should be incompressible.
It should be incompressible.
Incompressible.
Yes. What does it mean to be incompressible? What's the meaning of the term incompressible?
It means that the liquid cannot be made to occupy a smaller volume.
Cannot be used to occupy a smaller volume. Yeah, but we say that a liquid is said to be incompressible if application of pressure does not cause change in volume or change in density of the fluid. Of course, okay. So that is the way the hydraulic liquid must be. Incompressible, should not corrode the parts, have a high boiling point and a low freezing point. Of course, in most cases, we would want a liquid that is has lubricating properties. That is why in most hydraulic machines we have oil being used, okay? Because it is a lubricant. Because it is a lubricant. Okay? Anything you want to ask on pressure? Aaron, yes, your hand has been up for a long time. Yes, Aaron?
I forgot to light.
You forgot to, okay. Anybody with a question on pressure? Anybody with a question on pressure? Okay, what can we use to measure pressure? What can we use to measure pressure?
Spring balance.
Yeah?
Spring balance.
To measure pressure?
So we can use a manometer.
Manometer for measuring gas pressure, yeah?
Yes.
Okay. That's a YouTube manometer.
Yeah.
What else?
For atmospheric pressure, we can use a barometer.
Barometer, and there are at least 3 types of barometers, yeah?
Yes.
What are three barometers? Which one? You have a simple barometer.
14 barometer.
Yes.
Mercury barometer.
Android
Mercury
barometer.
And aneroid barometer. Aneroid, why would an aneroid barometer be preferred to others? Why would we prefer an anaeroid barometer to other types of barometers, especially for altimeters? Aaron?
Because it is
records small, it detects small temperature, small atmospheric changes.
Yeah, it's sensitive to small changes in pressure. Salim was saying something.
No.
Of course, it is potable. It doesn't contain any liquid. Yeah.
Yes.
So it doesn't contain any liquid. It is sensitive to even small, slight pressure changes. That is why to be preferred. And it's relatively portable. Of course, we have other types of gauges which are referred to as Bourdon gauges. Yeah. Bourdon gauges. So anything else on pressure you'd want to look at? Of course, some of the applications of pressure include, which are some of the applications of pressure?
They are used in lift pumps, car brakes, and
lift pump.
Yeah.
Lift pumps. Ephraim?
They are used in upstroke and bicycle pumps.
Upstroke, that is to do with either force pump or with the lift pump, yeah? Bicycle pump, syringes, yeah?
Hydraulic machines.
These syringes for injection and all that, yeah? A straw, when taking a straw, soda using a straw. Still an application of pressure, isn't it?
Yes.
Because when you use a straw, what happens? You suck air out from the straw, isn't it? Then what happens when you suck air from the straw? It produces a low pressure region inside the straw, yeah? So you have a low pressure region inside the straw. Then after that, what happens? Atmospheric pressure acting on the surface of the liquid that you're sucking pushes the liquid up the straw into your mouth. Sawa?
Yes.
Bekishon?
Yes.
Bekishon?
Yes.
Yes, seem to be saying something. Okay, anybody with any other question regarding pressure? Of course, you have the siphon. Also, it's an application of pressure. But the interesting thing about the siphon is that if the flow starts and you move it from the position and move it to a vacuum, the flow would continue as long as it has started, yeah? Because the excess pressure will drive that with the siphon. Sawa?
Yes.
Okay. Anybody comment? Have we gained anything from the session?
Yes.
Yes.
I hope we are meeting our expectations, yeah?
Yes.
Yes.
And that's a good.
Yes.
Please, as you continue, do as many questions as you can from the topics, yeah?
Yes. Yes.
Do as many questions as you can, especially with textbook. Then if you come across any difficulties, then maybe if we meet next time, we shall have time to discuss them, yeah?
Yes.
Yes.
Okay.
Yeah.
Anybody?
Yes.
Any comment?
What about the results?
The
results for the end
results.
of term. Yes.
you'd want to have the results.
Yes.
I guess they they should be okay. The three they've been handed. I don't know whether the report cards have been prepared, but the marks had been handed in.
Okay.
You want to get them from such a forum?
Maybe on the group.
You want us to get it that?
Maybe on the.
Or how do you want us to go about it? The group.
Yes.
Or
They can be posted
WhatsApp
in the group. Yes.
The result.
Yes.
All the results or just the physics?
Physics.
Do you want the physics results to be posted?
No.
Okay, I'll make
No, man. Yes. No.
There's somebody who has a dissenting view. There's somebody with a dissenting view.
I know.
Who is saying
Mwalimu,
no? Yes.
we wait for all the
Well, you know this situation where
Let's wait for all of them.
please mind your language, yeah?
Yeah.
I know you'll get results maybe by then. I don't know when, but you get them. And since some people are not for it, let's not post it, yeah?
Yes.
So that we are sensitive to everybody's plight. Sendio?
Yes.
So that we are sensitive to everybody, let us not really post them. But maybe if you want your results, you can speak to Miss privately, yeah?
Okay.
Oh.
Sasa?
Yes.
If you need if you want to know your results, you can talk to me privately.
Even now.
Namba iko utaipata tu, yeah? Sawa?
Yes.
Okay, guys, I just wish you all the best. Please take care of yourselves, yeah? Please take care of yourselves, please. Take good care of yourselves.
Yes.
Please watch that you're not misled, yeah?
Yes.
Make sure you're not misled. And don't also mislead others.
Yes.
Yeah.
You know some. Okay. Sawa?
Yes.
Yes.
Okay.
Good.
Yes.
So we'll catch up later.
Yes.
Okay, all the best.
Yes.
Yeah.
Yes.
God bless. God bless. God bless you.
Thank you,
You
Mwalimu.
too.
Thank you, Mwalimu.
Thank you. Welcome.
Amen.
Welcome. Ni nani analea mtoto jameni? Si take care of that. Don't mwambie acha kufinya mtoto.
Anapigana.
Hapana, asipigane.
O'Neil.
Yeah?
Is it O'Neil?
No, it's not me.
Odile is fighting with his sister.
Don't worry. It just shows that people are responsible. Don't worry. And of course, they'll be fighting for the phone. Sawa, all the best. Sasa tutazidi kuonana.
Thank you.
Welcome.
Asante Mwalimu.
Thank you.
April Fools. Caleb nimekurickroll.
April Fools.
April Fools. Sasa nyinyi mnasema nini?
Swali mnyamaza.
And niulize, who that was clapping during the lesson?
Ongoto.
Ati Matilu unauliza aje?
Who that was clapping during the lesson?
Ongoto.
Naona kaa ni wewe, sijui mbona. Naona kaa ni wewe.
No, it was Ongoto.
Some guy
Wait,
was
so guys, do you know Mr. Odor is still in the lesson? Is still.
Do you know your sister is still in the lesson?
Why leave?
Wait.
Bye.
You